Okay, let us begin. So I'm curious to see if anyone else actually shows up. It was supposed to be a review week, and so once again, probably feels like it's best to just continue on with where we left off for the questions. And so I've got that up from where we were before. Technically, we stopped before triple I. Did you end up having a look at the triple I thing, giving it a shot?
No, I didn't have time.
Didn't have time. Okay. Um, Yeah, it won't hit the same as before. I'll briefly touch on it, which was we had some function h, which was a copy of f, but has a different domain. And we were told that the graph of h was shifted right and up by a certain amount. And eventually the goal was to figure out, okay, what must the domain of h of x be? And, the natural thing to do is to think, okay, it's being shifted up and right, it's being shifted right, the domain probably also shifts right. However, that's not necessarily what's happened, because h of x started like this, and so if it shifts right, then the original domain to map onto g of x had to have been before the domain of g of x. So to put into perspective, g of x has a domain of 0 to 2 pi, h of x is shifted forward to match that. And so for that reason, h of x must have been pi over 2 behind if shifting pi over 2 forward completely matches the domain. It was a very nasty trick. It was single digit percent pass rates. Probably doesn't hit as amusingly as it would have been if you had done it immediately after, but that's fine. That's that one. Cool. Question 7. Tile maker, two separate conditions that have to be met. We're essentially tessellating these tiles so they connect to each other at the ends. That's what this is all about. Each end of each tile needs to connect to the next end of the next tile. The other condition that has to be met is that each color covers half of the front surface. So you've got grey for one half and then white for the other half. It's an exact 50-50 split. Type A's look like this. Type B's will then presumably look like this. First up, find the area of the front surface of each tile. Fairly simple question there. Area of the front surface. Should probably give you another copy of these, shouldn't I? Let me grab both of those, solution and document, so you can pull up on your own as well. Alright, those should be sent.
Would we times like because area, so length times width.
Mm-hmm.
So just 20 times 20.
Yeah, 20 by 20. Exactly right. Now there's going to be one final thing to put on that. You don't just give 400. You give what?
Centimeter. Oh, squared, yeah.
Centimeter squared. Yes, that's it. Nice. Cool. All right, that's that one. Nice and simple. Part double I. Find the value of A so that condition 1 is met. So condition 1 means that you got a 50-50 split for the tile, and A is the addition on f of x there. Find the value of A so that type A meets condition 1. It's 1 mark, so you can assume that there's probably some sort of hack to figure it out immediately without doing too much effort. I'll let you have a think. I guess it's important to understand, like, what does this function actually tell you about the tile? And it's telling you essentially about the line It's the equation of this line that's dividing everything up. The other thing is that the condition is that you have to have that line such that area below is the same as area above, right? It's 50-50 split. So if you think about what A is associated with, how does A change, or what impact could it have on the area above and below the tile, above and below the line? Any ideas so far?
Would we have to sub something in to
You could.
find?
You could sub something in. It wouldn't be a point that's immediately known. Like none of these would be points on the line. You can kind of guess where that point would be if you were to. Um, Maybe one question to ask. So you got this function. It's a circular function. What does plus a at the back end normally do to any circular function?
It moves it up.
Yeah, up or down. Right. So if you imagine, so plus a, in fact, specifically with circular functions, yes, it moves it up. What other key feature is it associated with? This is specific to circular functions. What does plus a tell you about like when you sketch a circular function? It tells you something pretty much immediately.
How far you have to put it up.
Yeah, yeah. Fair enough. I was sort of more thinking on the lines of like it's the new mid-level of the circular function. So whatever your vertical translation is becomes the new middle line. If you're looking at this, the middle line, for it to be 50-50 split, top and bottom, you want your middle line to be dead center of the tile. And so if it's 20 high, then you're going to choose your A value to be 10 there. That's the most straightforward way of going about it. Just saying, cool, I want to split it 50-50, so A is going to be 10. If it's tough to find that out, the other thing you can do is make use of integrals, right? Like in the sense that, oh, area below the curve I can do with integrals, right? So I could take the integral of this from 0 to 20, and I could make it equal to, what was it? We have a total area of 400 centimeters squared, so for 50-50, you would then choose like 200 to be what the integral equals. That'll be a lot of effort to try and fit into two lines of working, but you do have, I guess, all of this underneath as well to make that happen. So better than losing the mark, I guess. Make enough sense?
Yeah.
Cool. Next up, tile B. Very similar thing. This one's given by some nasty cubic. Show that type B tile meets condition 1. So again, condition 1 is the exact same thing. Each tile covers half the front surface. Or each color, sorry. So you want that 50-50 split once again. Bit tougher with this one now. We can't use the same little hack that we had before, which is setting a midline. Cubics don't really have that sort of thing that we could make use of.
Could we do an integral from 20 to 0?
Yeah, yeah, precisely. That's the only other option we have available to us, integrating it up. Yeah, so integral of that, definite integral. Yeah, have a go with that. I was debating whether or not to actually let you do the whole. Do you want to do the whole math of it, or do you want to just sort of see it and practice this sort of stuff in your own time?
Yeah, I think that's good.
it's good for you to practice it?
Move on.
To move on? Okay, cool. So what that looks like is this. You got this big nasty integral, antidiff it, so cubic becomes the quartic, capital F of top minus capital F of bottom, and then eventually you're just going to get a number of 200. Now, you do have these big nasty numbers in here, and that does become quite time consuming. And so one of the things I can recommend there is to actually sort of break things down into common factors. Like this 400 in here, you can split the 4 off of it and make it 10 squared. And so eventually the idea is you keep splitting things down until you can cancel things out a lot nicer, rather than having to expand everything all the way out and then simplify it all the way down. But yeah, you've got a copy of those notes so you can refer to that when you do them yourself. Cool. C. Determine the endpoints of F and G on each tile. Hence, use these values to confirm type A and B can always work, essentially. So we're trying to make condition 2. Condition 2 is that they will always line up no matter what way you put them, left or right. So you can put this one to the right of this, you can put it to the left of it, it'll produce the same result. And so the first thing they get you to do is figure out the endpoints of F and G on each of the tiles, and then use that to say, yep, this will definitely work out. So there's 2 parts there. How could we get the endpoints of F and G? How do we get the endpoints of any function?
Subbing in
Yeah, what do we usually sub in?
the coordinates.
Yeah. Well, to get the endpoint, like the endpoint is the coordinate, so it's usually you'll have like a domain, and then you'll sub in the first and last value of the domain. That's essentially what we're going to do here. What are our first and last values of the domain?
0.
0 is one of them. Yep. That'll get you this left endpoint.
And 20.
And 20. Yeah. So if we have a look at what that looks like, solve f of 0 and f of 20. Solve g of 0 and g of 20. Those will all give you the same answer, y equals 10. All you'll need then is a final statement. Now that you have those 4 y values, why does that mean that condition 2 is met? And I'll show you what condition 2 actually was again, so you can refer to that. Why is it that they have the same y value that makes it so they can meet condition 2?
So all of them can like be put in any order, or like, yeah.
Yeah, precisely. So you basically say something to the effect of, in fact, what did I write here? Basically, the fact that all the endpoints, left and right, are identical means that you'll be able to tessellate them however you please. Because if they were ever so slightly offset, like if this was 10 and this was 12, then you wouldn't be able to do left and right. You might be able to do, if this was like 10, 12, 12, 10, that could work out, but not in every single order. As soon as you flip that around, not going to happen. So as long as both left and right are the exact same thing, doesn't matter what order you put them in. As long as you're doing left to right, of course. Up and down, that's not going to work out. And so that's more or less what you would say. Something to the effect of same y value, therefore always works out therefore a horizontal line always works. Something to that effect. Because part of the question is confirming that this works. So you do got to put some sort of explanation into that. This one I remember being a bit interesting. This was one of the first exams I wrote solutions for, and so I was kind of fresh and new to remembering methods again, and I think I got it wrong. We'll see if you do better than me when I was relearning. Question 8. We've got this function capital A of k, and it gives the area bound by the graph of f and the line x equals k. State the value of capital A of pi over 3. That one should be fairly chill.
Just subbing it into the k sine k.
Yeah, that's stock standard. You've got A of k, A of pi over 3. It's right there in front of you. Nice. Fair enough that sine of pi over 3 is root 3 on 2. How's your unit circle stuff?
Yeah.
Yep. Easy. Here's the one that I struggled with. F of pi over 3. Not A of pi over 3, but F of pi over 3 now.
I'm not sure how you would change it.
Yeah, it's basically was my my first impression when I saw this for the first time, way back when, maybe 2 years ago or so. The first thing I would point out would be, what actually does A of k even mean in this context? So let's make sure we're clear on that. What does A of k actually tell you in this scenario?
Is it defining the function?
No, not defining the function. A of k is the rule that gives the area bound by the graph. So A of k is actually gives you area. It's an area function, not the graph. F is the graph. So you can see the graph f of x, it's called the graph, that's the line. A of k is the area under the graph. So that really helps to at least know what the difference is between A and F. What do we normally think of when we think about the relationship between area under a graph and the graph itself?
Integrals?
Integrals, absolutely. So if you wanted to find the area under f, you would what? Just for any other function, just some random f, what do you do to find the area under?
Find the integral of f.
Integral of f, absolutely. Trouble is we don't actually know what f is. So we can say the integral of f does give me the area under f. But I actually do know what that is, because I know the integral of f is this, right? Or at least the definite integral of it is that for a specific value of k. So this actually is the antidiff of f, right? Because it's the area of f. So I have this statement that says integral of f is equal to that. How do I now get back to f? We've now paired them to.
You antiderive a of k. Like you find the integral of it.
Not antidiff, but diff. Because this one already is the antidiff of this. You go from f to a of k via antidiff. So to get back from a of k to f, you diff. Right? So you got, it might make more sense if I write it out a bit. So we have this statement here that says integral of f is equal to a of k. And so if you want to get the f on its own, you would have to diff both sides of this equation, because diff would cancel out the integral. And then obviously the diff on this side would now work out. Now I know I'm using a's and I know I'm using x's and k's in the same thing. That's sort of besides the point. You just replace the k with the x, at least for now. But yeah, fair enough, the relationship there.
Yeah, that makes more sense.
Okay, so if we know that we're going to go and diff a of k, what rule do we have to use to diff that?
We could use product.
Yeah, product rule. You got k times sine of k, it's a product rule thing. So we go through and product rule it all. That's what all this looks like. Whoops, went a bit too far. So I wish that AI thing would piss off. There we go. That's better. So you've got your product rule all the way down at the bottom there. That gives you f of x. We got back there. Now that we have f of x, what's the final thing we should probably do?
Sub in pi on 3 in
Sub
that.
in pi on 3. Yeah, that's it. Chuck in pi on 3, and then use your unit circle stuff to simplify from there. Tough question. Make enough sense how it works there?
Yeah.
Cool. Yeah, I think part of the fact that there was a K in there made it a bit weird. The fact that it sort of cuts it off, or at least it appears to cut it off early, kind of makes it a bit tougher to observe that they're still related in an integral type relationship. Even though it looks like K is cutting off earlier, that's just a specific value of K to cause a definite integral rather than an indefinite or just an antidiff. And then lastly, average value of f. So now we actually know what f is. It's we have that one right there. Find the average value of f over that interval, and we're told that k has a domain of 0 to 2. Find the value of k that results in the maximum average value. That's the goal. What k will give us the maximum average value. There are a few steps there. Don't have to do it all at once if you can't see it all the way to the end. I'll let you have a think, and when you're done, what kinds of things would you start doing to get closer? Keyword average value means something very specific. Do you remember what that's referring to? The specific formula? The specific calculus formula?
Would it be like one of the rules of the integrals?
Yeah, it's got to do with the integral. You're right. Now the specific equation is this one here. So it's the 1 over b take a, and then you multiply that by the integral of a to b. Right, so you basically integrate over whatever domain you're given and divide by the length of that domain. So we're told to do it from 0 to k, and so that's what we do. We got k and 0, we got k and 0. This right here is f of x. It's the function you're trying to find the average value of. So we're trying to find the average value of this function, so that's why that function gets into that spot. Fair enough so far?
Yeah.
Okay. So that's how we get average value. We're trying to maximize average value. Now, it's probably a bit early to start thinking about that. Maybe one thing we can start considering is how do we actually simplify this? Because doing this integral is actually a little bit tough. Specifically doing the integral of x cos x. You would have done it a couple of times in the textbook, specifically x cos x. So you can have that memorized, although the intention is not to have it memorized. Um, if you were to do this integral, what do you think that comes out to be based on what we discussed earlier? Remember this, have a think about how we actually got to that f of x thing. That's what the thing in the brackets actually is, or the thing in the integral, is f of x. How did we get f of x? What was our working out to achieve that?
To diff it.
Yeah, diff it. Precisely. We did the diff of the a of k. And so that actually just came with the revelation that the integral of f is a of k. This is the integral of f. And so, well, we already know what that is. It's k sine of k. Or if you just, replace it with the x's, you've got that sorted. So just doing that anti-diff section, we already know that's just x sine x from earlier. We're just going back where we came from, essentially. So that gives us this, and then obviously the rest of it's going to simplify a little bit nicely. All right, we can just continue solving simplifying that average value equation. Capital F of top minus capital F of bottom. That's that bit there. And that eventually gets you there. Average value is the same thing as sine of k. We want to maximize that. We want to find the maximum of sine of k, or at least the value of k that gives us the maximum. You might have seen a sneak peek of it as I was scrolling down. And you might know off rip where the maximum of sine of k would be. If you just think about like the graph of what sine actually looks like, what maximizes sine?
Pi on 2.
Yeah, pi on 2. So, if you just picture the graph in your mind, pi over 2 is that maximum. Otherwise, if you, for whatever reason, have a brain fart in the middle of the exam, whenever you want to maximize a thing, you can then diff it and then derivative equals 0. That's another thing you could do. Diff sine becomes cos. Cos to 0 happens at pi over 2, 3 pi over 2, all that sort of stuff. Yeah, that's that. And that's the exam. So, no one else has joined. I'm curious if there's anything specific you would like me to go through, or would you rather me just pull up another exam?
In school, we've been going through the 2022 one as well.
Nice. Brilliant. Take active or take free?
This one, tech free.
Yeah, there you go. All right, you got the whole thing now. You'll
Yeah.
crush it. You look amazing in front of everyone. Nice. Cool. All right. So I think if there's nothing in particular you want me to have a look at from there, I can just pull up the. We're supposed to do the tech active version of it on the Tuesday, but we'll just sort of do it now. I think that's fine. Let's see here. So I'll put that in chat. Do you want to look at multis at all, or you're happy to just go straight to external response?
I think extended response would be good.
Yeah. Sounds fair. Okay. Still screen sharing? Yeah, cool. All right, so you got your copy of the PDF and the solutions along with that if you would like to follow along there. Otherwise, yeah. Question 1, axis of symmetry of this graph. Should be fairly stock standard.
Would it just be 0?
Yeah. Now, I would say make sure you say x equals 0. That's the more accurate answer when you put it in there. But yeah, x equals 0 is what you're looking for. Nice and simple. All right, part B. State the derivative of f with respect to x. This should also be quite chill.
On my CAS, I got x over 6.
Yep, x over 6. Nice and easy. Tangent to f at point M, so there's your M over there, has a gradient of -2. Find the equation of the tangent at point M. It's a bit nastier because now you can't use the CAS tangent line function anymore because you need an x value for that. We don't quite have one. Well, at least not immediately we don't.
Could I make the derivative equal the gradient?
Absolutely, you could. That'd be a great idea. Yeah, derivative equals gradient. That'll let you solve for x.
I got negative y equals -2x minus 12.
There you go. Yeah, sprint it all the way to the end. You got your x value from the derivative equals -2, and then you sub that into tangent line, I'm assuming.
Yeah.
Sweet. All right, here we go. We've now got a normal line, a perpendicular line, coming off of coming off of M rather. Find the equation of that line. Yeah. How do we do the perpendicular version of that?
I got y equals x on 2 plus 18.
Yeah. Was that the CAS normal line function?
Yeah.
Easy. Very good. The line perpendicular also cuts f at the point N, which is over there. Find the area. Yeah, find the area enclosed.
I'm not too sure how you do this one.
Okay. Well, if we ignore what's happening as far as like all of this specifics, how do you normally find area enclosed by two lines? So we got some F, some G, and they make a bound area. What's the overall process for that?
Is it like when we sub f and then g as well? Like that whole equation?
Yeah, I mean, there's going to be some sort of equivalence between F and G. Yeah, we do need to do that. That'll help us get the endpoints, right? So part of finding area bound between two separate curves is figuring out where they intersect each other. So we already know m. That was the negative 2, was it? Negative 2, I think. Where was it? Negative 12. Yeah, okay. So we already know that one's a negative 12. And to get the other one, well, yeah, as we just said, let the two equations equal each other. We already know the equation of the normal line. We know the equation of the quadratic. And so, CAS solve gets both of those. That is this. So there's the quadratic equals perpendicular, rearrange, solve, however you want to go about that. That gives us our two endpoints there. What's the other concept that comes with area?
Integrals.
Yeah, integrals. So the basic rule, should I keep going or do you want to have a stab at what you do next?
You go.
Okay, so it's a top take bottom scenario. Anytime you have an area bound between curves, so the keyword area bound between or enclosed by two things, as long as it mentions anything other than just a function and x-axis, as long as there's something else involved, you do top take bottom. So you're still doing integral from start to finish, from negative 12 up to, what was it, 16, 18? 18. So still doing the integral up until that point, but you're doing top take bottom, which is this minus that one. Oh, sorry, other way around, my bad. This minus that one, because your top, the thing that's on top, is that straight line. And so when you do that, there's your linear minus the quadratic, integral over that domain, and that's just there for you to run with. Cool?
Yeah.
Yes, that's always the process you follow for any bound between two curves. You're pretty much guaranteed to have this on the test. So this is one you'll definitely want to work on a lot. Here's another thing. Cool. So we have a quadratic that looks quite similar. Like basically this is the same picture, but now they've chucked A's and B's in there, essentially. And, you still got your tangent, you still got your normal. Find the value of B in terms of A such that the shaded area is a minimum. So it's still like find thing such that we minimize area. We did a similar thing just before. Find x that maximizes average value. Same sort of idea. The actual arithmetic is going to get quite tough. Good thing you have a CAS. So if you think about the overall process of minimizing area, what kinds of things do you have to do? You can even like picture the fence example where you have like a perimeter and stuff like that. Like how do you do maximum or minimum area type stuff?
Could we use the CAS like the what's the function?
F max, F min?
Yeah.
Yep. F min should work out fine. Now, F min of what is the thing? What do you actually put into that F min?
Of G of X.
Well, if you just do G of X, you'll get this origin here because it's F min of G. You want F min of the area, so we need to get an area equation out of this. How are we going to work towards getting the equation of the area?
Do we find the integral of G of X?
Sort of. Integral of G would give you area under G, so it would be all this white stuff underneath G. It's what we did before. How did we get this shaded area before? It's a very similar setup. What were the broad strokes stuff we had to do? we'll walk it back a bit then. We need to get our bound area equation. How do you get bound area for any two lines?
Um, I'm lost.
Oh no, weren't listening. Oh no, how sad. It's fine. Yeah. So top take bottom is always what we're doing for bound area. You want to figure out what the equation is on top and then minus it from the equation on bottom and do the integral from here to whatever this is. So we're literally just repeating exactly what this was before, right? Like this is x squared over 12. This one is x squared over 4a squared. Same shit. It's just some number on the bottom, some coefficient. And so fundamentally, every single step we do is going to be identical. We already have our equation on bottom. We don't have equation on top, but that's just a normal line, specifically the normal line at x equals negative b. So you would just cas normal line at negative b to get that thing. Then whatever that comes out to be, you do top take bottom, the integral from here to wherever this is. Now to get this, well, you'll have this equation already. You know what g is, so you just do, again, normal line equals g, and that'll give you that point. That'll give you your area equation, and then you f-min that. So I was talking about a high level because if you have a look at the actual math, it's ridiculous. Like that. So that's kind of why I was talking a bit higher level on that. But yeah, you can see you get your perpendicular line. There's your CAS syntax. There's your function. You're doing it at negative b. It's going to give you that. This is now solving the other end of the integral. Right? Take that perpendicular line, make it equal to the quadratic. That gives you the other x value for your integral. When you integrate, you get this nonsense, purely in terms of b, of course. And so you do, I've done diff equals 0, and then figure out which one's which. You can just do f-min. That's perfectly fine. In fact, it's better to do f-min there, I would say. I wrote this again, like when I was starting out tutoring. I didn't have all the tips and tricks I do now. And so yeah, f-min is a lot better there. Nasty shit, but that was kind of why I was hiding it, because you're following the exact same steps. Do perpendicular line, find the boundaries in the exact same way, top take bottom in the exact same idea, f-min to minimize that area. The only trick there is making sure you f-min for b, not for a. It's b in terms of a. Cool?
Yeah.
Okay. Tough one. Yeah, more circular function stuff here. So we got foxes and rabbits. Here's the graphs of foxes and rabbits. You're told a minimum, but it's already on here as well. Maximum, it's also on there as well. Rabbits is that one. Find the initial population of rabbits, whereas this is a population equation. Initial population.
Would we just sub in 0?
Something at 0 sounds like a really good idea. Yeah. Nothing crazy. Define it in your CAS, sub in 0, you're going to get 2500. Nice. State the minimum and maximum possible populations. This one should also be fairly quick. You can
Um, for the max, I got 4,200,
Yep,
and then for the min, I got 800.
brilliant. Good thing you did not get caught with this. This is not the rabbits, this is the fox. Sweet. Triple I. There's also a couple of ways you could do that one. State the number of weeks between maximum populations of rabbits. There actually is quite a few ways you could do this one. Some will definitely take longer than others. You have an approach in mind, or are you still thinking about it?
I was just trying to look at the graph.
Oh yeah, just eyeball it off of the graph numbers. Because that works. Absolutely it works. Because the peaks are on an axis. So you can see that one's a 40, that one's a 200. And so yeah, from peak to peak, you can definitely just do that. Yeah.
Is there another way? Because it's kind of hard to look at the graph.
I mean, it's hard because you're looking at digitally. If you had the actual paper in front of you, it'd be pretty obvious that this is a 200 and this is a 40. So the difference between 200 and 40. So you've also got 160. That's probably the easiest way to do it. Next up would be calculating period, because by definition, a period is just going to be the time between peaks, the time between troughs, however you want to define that. It's a circular function. It's the same shit either way. So you could just do the period of the function. That'll get you 160. You could plot this on a CAS and then use the graphing tools to measure the peaks off of that. You could diff equals 0 and find those via the CAS tools. I think that was all I could think of for now, for all the different ways you could do that one. But yeah, not too bad. Make enough sense, yeah?
Yeah.
Yeah, so I think the take home message, like this one, there was a lot to do. In other cases, there's not really that level of flexibility. And so anytime there's circular functions and there's something about between max, between mins, between peaks, between troughs, it's probably going to be related to period. If not exactly the period, maybe a fraction of the period. Like for instance, if it said from peak to trough, that's a half of a period. But it's still going to be related to the period of the circular function. Okay, part B. Foxes are this one. There's some unknown stuff in there. Show that A equals 900 and B equals pi over 80. Have you got your own PDF open, or do you need to see the other stuff? Because you do need to see the other information.
No, but I can pull it up.
Yeah, okay. There's also a bit of flexibility on this one. Any ideas so far?
Um, I'm thinking about like what they've given us and like subbing it into the f of t.
Yeah, yeah, okay, cool. So the yeah, because it's foxes, you're subbing in these points.
Yeah,
Yeah, perfect. That's a really good idea. That's the solution that I have up here in the written version, which is yeah, sub in those points. You get two equations with two unknowns. Well, actually, only no, two unknowns. You're right. Yeah, A and B. Um, and then yeah, simultaneous. So simultaneous will get you both the A and the B off of that. It's a fairly lengthy way of doing it. Um, how much lines? You've got enough lines working to make it happen. It might be just so I can show you like a few little hacks around how you might simplify things. It's good to think about what A and B are related to. So A is related to the amplitude of the function, and B is related to the period of the function. And so some of the things you can start talking about would be something like, okay, the amplitude is just the distance from, or if you wanted to be super succinct, you could say the amplitude is half the distance between the middle, the peak and the trough, right? Because it's from middle to peak is what it's supposed to be. The other way you could say that is half of this. And so what you could do is you could do the distance between these 2 points, halve it, and then that's your A value. That might take you like 2 or 3 lines of working. And then for B, well, again, since that's related to period, you can say, cool, from peak to trough is 80. That's half a period. So half of 2 pi over n, or in this case, you say B, 2 pi over B is equal to 80, and then rearrange that way. Both of those will get you to the values that are here as well. That second approach that we just discussed now is going to rely more on understanding of circular functions. The first approach is just a generic, I've got two unknowns, two equations, simultaneous. Fair enough for both?
yeah.
Sweet. Yeah, we should have time for this last one here, part C. Maximum combined population of foxes and rabbits. Bit tougher. Oh, no, it's Kaz. This will be fine. Tough to do by hand, probably.
Would we just sub it in and add like both fox and rabbits?
Yeah. Sub it in both. How? So, what exactly do you mean by like adding both fox and rabbits?
Like adding the um the maximums of
So, this peak here to this peak here, adding both of those.
yeah.
Challenge with that is that those occur at different times, right? I kind of gave the hint, which is doing this by hand will be very difficult. If that was the way of doing it, that'd be quite easy. The problem is, this is at a specific time. Like, if you have a maximum here, you have almost a minimum over here. You can't quite just grab this max and add them together. What you do have to figure out is where on this graph does the aggregate addition give the biggest possible value? And just by eyeballing it, it's probably somewhere over here, right? This y value plus this y value is probably as big as it's going to get. Maybe it's around here, something like that, or around here as well. Point is, you don't have to really eyeball it. You just know that the total is always going to be the population of fox plus population of rabbit for any given value of t. Right? We have both of those equations already. We solve for a and b on the fox one, so we've already got those. This is just a Kaz thing. You'd already have this one defined anyway. Oh, sorry, you'd have this one defined anyway. This one you would now just put in as its own thing as well and add them up. Then for maximum, don't really do this bit. That's just an old thing. Just Fmax it. right? F max it over a specific domain. I did 0 to 160 just because that was that seemed like a reasonable cycle. 0 to 180 would technically be a proper thing because that'd be a full period. But it's more so just so you don't get infinite solutions. That'll give you some t value, sub that back in to get your max value. So p total being, I didn't even write what t value was, god damn it. 5339, where's that on the graph? Yeah, it's so hard to tell. It's probably around here or around here, one of those two. But yeah, have a play with that yourself, maybe after class if you've got a time for it. The only take-home message there is you have to keep the verticality of it consistent because they happen at different times. Fair enough?
Yeah, makes sense.
Easy. I'm having a memory failure. Did I drop in all of the past exam stuff for different there's 9 or so for each year level?
I think so. I think you gave the Google Drive the
Yeah.
different types of exams.
You've got it?
Yeah.
Yeah, okay, cool. Because I was going to say, you can start seeing how now there's matrices involved, not study design stuff. So what I'd recommend, I can only legally teach out of the VCAA stuff because I don't actually have licenses for those. That's just a thing that I have access to. And so that's why we're doing the VCAA stuff. In your own study, I wouldn't do any of this, these ones. Max out the 2024, 2023 stuff because that's where it's actually current study design. I think 2023 counts. I don't really remember. Start in reverse order, basically. But all right, that's about it. I'll leave you to it.
Thank you. Before I go, could I ask you a question?
Yeah.
How do you recommend studying for exams? Because I know practice exams is the best thing to do, but if you don't remember the content, the certain rules and stuff, what do you recommend going over everything or how?
Yeah, so what I've been recommending is a once weekly you do under exam conditions. So you do a tech free and a tech active of probably the VCAA ones, because that'll be closest. If not, Heffernan is pretty close as well. You do one of them once week. Oh, sorry, you do a tech free and a tech active under exam conditions once weekly, and that gives you a benchmark to work off of to see if you're improving from week to week. The rest of the things I've given you, treat those as worksheets, essentially. Totally open book, as much as you want, even if it's tech free or tech active. Use CAS, use non-CAS. I don't really care. You just got to make sure you're try to treat the tech free like tech free. Try to treat the tech active like a tech active, but just make them as worksheets because before having access to that, the recommendation was still the once weekly benchmarks, but going into the textbook stuff to practice those once you know what you're struggling with specifically. And I guess that's still true. If you can see there's clearly one outlier of okay, I really suck at this, then do the textbook stuff on that.
Okay.
But if you're overall just sort of doing okay with most of it, practice exams are going to be the way to go on that. And you just grind them out like worksheets, and then once weekly benchmark where you're at. If you find yourself not improving, let us know. Happy to try and support further. Whether that be to try and improve the approach, or maybe even consider doing some private lessons up until before the exam, because it'll only be a short duration of it if you want. But yeah, that's the recommendation.
Yeah, thank you.
No worries. Take care.